Hi everybody, I hope all of you are doing great. Today we're going to solve a dynamic programming problem, which is of course string-based dynamic programming problem. And of course, right now I'm taking up the string-based lectures, right? This problem is a very famous problem and it might look very difficult in the first, you can say, read, but it is actually simple problem. It is like given hard as well. They have written that this problem is very hard. Okay, it's hard, right? Without looking at this difficulty level, right? This problem is actually a very simple problem. It's just involving the pick not pick strategy, which we have already seen in this DP series itself. Let us read the problem. Given two strings S and T, return the number of distinct subsequences of S which equals to T. Modulo 10 to the power 9 plus 7. This is like, we are not talking about this right now. Ignore this particular phrase. Just look at this problem. You are given two strings S and T. You have to return the number of distinct subsequences of S. So subsequences should be from S which are exactly equal to T itself. Okay. So for example, here you can see the example itself. RA triple BIT, RA BBIT. You can see these are the three subsequences which are getting formed from this particular strings which are equal to this T. You can see RABB and then this IT is equal to rabbit. RA BBIT is equal to rabbit, right? And of course, like this is subsequence, right? I hope you understand what is the subsequence itself. I'll discuss that as well. Don't worry if you don't know it, right? So, like let's look at this problem. What this problem is actually saying on the board itself. Let's understand it more clearly. So we are on the board itself, and before getting into the problem, let us understand what is a subsequence. I've multiple times already picked up this topic of subsequences. I'm just doing it if you are directly watching this video and you don't want to watch the whole series. I'm explaining this topic again, but it would be really helpful for me as well, and it would be very helpful for you as well if you follow the whole series. This whole dynamic programming series is in a proper structured order. Videos are definitely a bit longer than all the other DB series you'll be finding on the internet, but I would say that the videos are longer because I try to do the whole recursion tree. I try to complete the recursion tree itself, right? So that you understand how the recursion actually working, right? Because DP is actually about recursion only. If you understand recursion very beautifully, then DP is just an optimization over it, right? So before wasting any time, you can of course check out the whole playlist. Here somewhere you'll find the I button link. Let us look at this particular thing. What is a subsequence? For example, this is a string A, B, B, C, C, right? So what is a subsequence, right? Any part of a string, any part of the string. For example, I'll take this part A, B. It's a part of a string. I take A and C. They both are part of the string. Definitely they both are, right? I take, let's say, A, B, B and this A, B, B and this C. Definitely this is also, every character present here is present in the string. Definitely. So the first condition, that in your subsequence every character should be present in the string itself, and every character should be in a proper order. So A is coming before B, this B is coming before this B. Definitely we are in correct order, and B is coming before C. I cannot write CA. This is not a subsequence, my friend. This is not a subsequence. You can say C is a subset. It is a subset. It is not a substring. It is not a subsequence. It is a subset, because subsequences involve around a proper order. You can pick characters by like leaving characters, some characters in between, but the characters you have picked should be in a proper order. A, C, they are in a proper order. A is coming before C. So this is what a subsequence. What is a substring? Let's discuss that as well. A continuous segment of a string is a substring, right? So if you are not leaving any gaps in between, that is a substring. If I take this, that is a substring. If I take this A and then this BCC, I've leaved this B from between, so it's a subsequence, right? And of course, we can of course say that every substring is a subsequence, but not every subsequence is a substring, right? So I hope this thing is clear, that what is a subsequence. Let us now look at this problem, right? What this problem is actually saying. These two strings are given to you. This is string S. Let me name them. This is string S and this is string T. You want to find all the distinct subsequences which are equal to this T. Of course, the distinct subsequences from should be from string S itself. Okay. Let us look at an example. So I'm calling this, there are two A's now, there are two A's. So I'll call this A as A1, I'll call this A as A2, I'll call this C as C1, I'll call this C as C2. I'm not actually, changing the string. I'm just naming them that, if I will refer this A, I'll say that it's A1. If I'll refer this C, I'll say it's C1, right? Because they are duplicating, right? So let's see what is going to happen. Is this a proper subsequence? Is this a subsequence? Let's say A, A1, B, C1. Yes, A1, B, C1. And can you see that all the characters here, A, B, C, are equal to the characters of string T? Definitely they are. So can I count this as one of the distinct subsequences which I want to find? Yes, definitely I can count. Because this particular thing is present in string S and it is actually equal to T itself. Okay, let's take another example. Let's say I choose A1, B, C2. A1, B, C2. Now you can see I'm not selecting C1 here. I'm not selecting this C here. I'm selecting this C right now. But still this thing is coming out to be equal to T itself. And of course it is different than whatever we have found so far. Right. This is distinct and it is equal to T as well. So I can count this person as well. Great. Now let us try to find some, we can say, combination with A2. A2, B, C1. A2, B, C1. Great. No issues. No issues. It is different from whatever I have found so far. Definitely it's different. I'm using A2 here and it is equal to T as well. That's great. Let's see some other example. A2, B, C2. Right. What is A2, B, C2? What is A2, B, C2? A2BC2 is simply A2BC2 is simply another distinct subsequence which is equal to T itself from the string S itself. You can see this, you cannot find anything which we have found, previously, which is equal to this. Definitely. And of course it is equal to T as well. So these are the four distinct subsequences we are able to find in this test case when S is equal to this, T is equal to this. I hope this is clear. So the answer for this test case should be 4. The count of, you can say, these whole things, right? I hope the problem statement is clear to everybody. You want to find the count of distinct subsequences from string S which are equal to string T. You cannot skip any characters from string T. You have to take all the characters. Your subsequence should have all the characters in this proper order, definitely, right? So just you have to find the count of them, right? You don't have to print these. You just have to find the count. I hope the problem statement is clear to you all in depth. Let us look at deriving some recursive approach for this problem and then move forward. So in this particular problem, we are dealing with subsequences and this pushes us towards the approach of pick not pick strategy, right? Because whenever you're trying to go through all the subsequences, right, of something, right? I'm saying that I'll be going through all the subsequences of this particular string, but with a certain condition, right? I'll only move forward in subsequences with a certain condition. I hope you remember the code for getting all the subsequences of a string or maybe an array using pick not pick strategy, right? And I'm exactly going to do that itself here. But I'll be calling, you can say I'll be altering my calls with a special condition, right? The condition which we have already seen in some of the string related DB problems. Let us see. This is the string S I'm having. This is the string T I'm having, right? According to this particular, you can say layout, this is the string S, this is the string T. I will try to match the characters of S with the characters of T. Let us look at how. I'll be only looking at the first character always, right? The 0th character. Look at this. A, A. Is this equal? Are these both things equal to each other? Yes or no? Definitely they are. What are my options? I can either pick this A or I can not pick this A. If I'm picking this A up, if I'm not picking this A up, I'm just only talking about this A. Do I want to pick this A or I don't want to pick this A? I'll write this like A1, A2, C1, C2, just as we saw in the example itself. So can I pick A1? My friend, A1, this A is actually equal to this A. Definitely I can potentially pick this up. So let us pick this A, and by picking this A means what? That I have matched one of the characters of both the strings. Definitely I am not concerned with these particular both characters no more, right? Anymore. So I can simply write here the remaining strings are string S is A2, B, C1, C2, and the remaining this particular string is, since A is already matched, the remaining string is BC from string T itself. This is the string S, this is the string T, right? Why have I not written A1 here? Because A1 is actually, A1 has cancelled out the A of this particular T, right? This string T, right? That's why I've not written A1 here. I've not written A here, right? I've picked that particular A up. That's what I'm trying to say. Okay. So if I've picked this particular A, what is the remaining, right? What is the answer which will be found from the remaining strings? What will be the answer found from the remaining strings? Let's see, full focus, देखो यार. Can this A match this B? No. So this says that there are of course two, you can say, calls from here. I can either pick A2 or I can not pick A2. Here, do I want to pick this A2? No, I don't want to pick this A2. Why? Because A2 is not equal to B. A is not equal to B. So from here, of course, 0 will be stored from the pick strategy, that there are zero number of ways. If you pick this particular person up, you'll not be able to form this person up, right? You'll not be able to form the remaining thing. That's it, right? But if I do not pick this A2, if I do not pick this A2, let's see. The remaining string S is B. You can say, since I'm not picking this up, remaining string is B, C1, C2, and the remaining string T is the same, BC itself. Why here is this same? Why here is the same? Because I didn't pick this character. Nothing got matched. So why should I cancel this B out? This A will not be able to cancel this B out. No. Here this A was getting matched with this A. Definitely we were basically calling ahead, right? We were calling ahead. I should rather write this like here, right? Because these are the two people which are calling everything, right? So I hope this point is clear, that here, since I'm not picking this A, the remaining string S is this much and the remaining string T is the same itself. I hope this is clear. I hope you are able to relate this from the previous problems as well. I hope you are able to get the recursion tree, whatever the recursion tree is going to be for, rest of the problem itself, right? Let us complete this recursion tree and then we'll move forward. One thing is for sure, that if you are following these DP series, it would be pretty much clear that how we are targeting string related DP questions. We are trying to match the characters, and according to that particular, you can say, variable, whether the character can match or the character cannot match, right? According to that, we are making the decisions moving forward, right? So here you can see there are two options, either to pick the B or to not pick the B. If I pick the B, if I do not pick the B. If I pick this B up, can I pick this? First of all, don't directly pick this B up. First of all, answer me. Can I pick this B up? Yes, definitely I can, because the zeroth character of T is actually zeroth character of S. So I can definitely pick this B up. So if I pick this particular B up, the remaining string S is C1, C2, and the remaining string T is C itself. I hope all of this is clear. That remaining string S is C1, C2 because B's has cancelled each other, right? So these are the two remaining strings. Now here there are two options, of course. There are two options. What are these two options? Either I can pick C1 up or I can not pick C1 up, right? If I pick this C1 up, what will happen? The remaining string S is C2. Remaining string T will be what? This C1 has cancelled this C. So remaining string T is empty. And since this is empty string, can I simply say that I have successfully found a way? I have successfully found a subsequence which is equal to all the characters of this string, because this is exhausted. This particular string T is finished now. This means that I have consumed all the letters in this particular string. This means that I'm able to form a thing, right? So from here, I'll not make any further calls. I'm going to return a 1, that yes, I found a way to make a string T, make a subsequence from string S which is equal to string T. I found a single way. That's great. No issues. Let's move forward. So what is that way? Let's see what is the way, right, which we are forming here, right? Here we are picking A1. So here we are picking A1. Then we are not picking A2. Then we are picking B. Then we are picking C1. Yeah, is this equal to the string T which was the original string? Definitely. So this is the first way which I'm able to find. So from here I'm going to return a 1. Okay. Let's call here, that let's make a call from here, that let's say if I do not want to pick this C1. What will happen? So if I do not want to pick the string C1, like this particular character C1, the only thing which is left in string S is C2, and the remaining string T will be as this, because I'm not picking this person, so I'm not cancelling anything, right? Now look at this closely. Here I'm going to make two calls, either to pick or to not pick, right? Either to pick this C2 or to not pick this C2. If I'll pick this C2, can I say no more characters will be left in string S? Definitely no more characters will be left. can I pick this? Like since I'm picking this C2, definitely I can, because this C is equal to this C. From here also nothing will be left. So as soon as my string T becomes 0, can I simply say that I have successfully found a way? 1 will be returned. And what is the way? What is the subsequence we are making here? Pick up A1, do not pick A2, pick up B, do not pick C1, pick up C2. So A1, B, C2. This is the second distinct way, second distinct subsequence which will be therein, which will be equal to string T itself. So here another way I have found. Let's look at this. I am not picking C2 as well. So am I left with any other characters in string S? No. String S is now empty. But how many characters are remaining in string T? C is still remaining. Because it was not able to match with anything, because we didn't pick C1, we didn't pick C2 as well. So you can see the string S is having nothing to match. So this is another base case. If T is having something and your string S has become 0, so this means that there are 0 number of ways you can form. Definitely. How can you match something which is not present, right? There is nothing in string S. How can you match? How can you make this? How can you find a subsequence which is equal to string C? No, it's not possible. You are going to return 0 from here. This will simply return what? The sum of both of these two values. I'll say that I am going to return a 1 from here. Okay, no issues. I am going to return this particular person will be returning a 2 from here. It will be returning the sum of whatever pick not pick. Let's make a call when B was not getting picked. Let's say I'm not going to pick B. This was the call for picking up B. I'm saying I do not want to pick B. C1 and C2 are left, and BC, you can say BC is the remaining string. Definitely B is still there in the string T, because I didn't match anything. I was not picking, you can say, the character, the first character of S. So great, no issues. C1 and C2, let us look at this more closely. C1 and C2 and BC is there. Great. C is not going to match with B. So we are not going to waste our time by making a picking up call, because we cannot pick this C1 up. There's no way. How can you match this C1 with this B? No. So we're going to directly write 0 here when we are picking C1. We cannot pick C1. We cannot find any way where we are picking C1 and we are able to form this particular person. No. I want to find a B here, but there'll be no way to get a B right now. Let's see. Not pick call. I'm not picking up this C1. So the only thing I'm left in string S is C2 and the remaining string T is BC. Can I pick up C2? No, I cannot. I cannot pick up C2 because C2 is not, the C is not equal to B. Right. So from here I'm going to return a 0. And I'll make a call when I'm not picking up C2. As soon as I make a call of not picking up C2, what will I call? Empty string S, because nothing is left in string S now. And BC is still there. So what is happening here? We have nothing to be matched with this particular string. So I'm going to return a 0 from here as well. 0, 0, 0, 0 plus 0, 0. And you can definitely see, my friend, if you do not pick this B, there'll be no way you will be able to form this particular string. If you look at this, how can you form a string from this much? You can say these all people. How can you find a subsequence? How many subsequences can you find from this particular string which are equal to this? No, right? None of them, right? Because B is not present here. Because of that B, you are not able to form anything, right? Okay, so from here I'm going to return 2 plus 0, which is basically 2 itself. I'm going to return 2 from here, and 2 plus 0. So this basically call will be returning a 2 from here. I hope this is clear to everybody. I hope you are able to understand whatever we did in the first iteration. This was these are the two ways I'm able to find when I'm including A1, right? Now let us talk about A2. Let's talk about A2. I'm going to complete the recursion tree, right? If there is memoization, that will be visible to us. Full focus. Dekho. A1, I'm not picking up A1 now. So the people which are left is A2, B, C1, C2, A, B, C. Okay. So now from here, I'm going to make two calls. Which is pick, not pick. Let me make some space. So either let me write it in correct colors, right? Which I'm using. So A2, since I'm not picking A1, B will be as it is, C1, C2 as it is. From string T, ABC will be intact because this A was not able to match anything else. Great. Two options. Either I can pick this A2 up or I cannot pick this A2 up. Always I'm talking about the first character. Pick, not pick. Can I pick this A2 up? Definitely I can, because it is equal to this A. So how many people are remaining? You can see BC, 1 C2, and the remaining people from this string is BC. Can you observe one thing, my dear friend? Can you look at these two cases? Exactly same cases, overlapping subproblems. Here we can apply dynamic programming to optimize. Should I calculate this again? Why do I want to calculate this again? And this is the meaning of dynamic programming. We do not want to do the repeated work, right? So you can say, I hope you have heard about bud optimization, right? So if not, I can definitely make a video on that as well. So it's just an optimization strategy, of your you can say codes, right? But yeah, I'm not going to make another call from here, because this is already calculated, right? This person always returns a 2, right? No matter what, you can make more calls, it will always be returning to itself, because there are two ways to make BC: BC1, BC2. And in front of them, if you have A2, you have two more different ways to make this particular string possible, right? So I'm not going to make any other calls. I'm simply going to return a 2 from here. This is the optimization. This is the memoization. I'm going to memo it from here, right? I'm going to remember this solution, and later when I need this solution, I will access this, and without making any calls, I'll directly refer to this solution. But if I do not pick this A2, if I do not pick this A2, this was the call when I was picking A2. If I do not pick this A2, you can see B, C1, C2 is remaining, A, B, C is remaining in the string T. Can I directly say, of course we can make more calls, right? But can I say that A is not present here at all? A is present here although. This means that I'll not be able to make anything, right? Let me complete, since we have done so far, let me complete the string tree itself. So two calls from here, either pick, not pick. You can see I cannot pick B. I cannot pick B because B is not equal to A. So I'm going to return a 0 from here. No issues. I'm going to return a 0. Remaining string S is what? C1, C2. Remaining string T is intact because we are not able to match any A. Great. We cannot take C1. Take call and not take call. Pick, not pick. We cannot take C1, so 0 will be here. And if I do not pick C1, I'll simply call for C2, A, B, C. Now you can definitely look at for yourself that C2 will not be able to match A as well. Pick, not pick. Pick, not pick. So we can definitely not pick C2 because C is not equal to A, right? And definitely you can see that the remaining string, if I'm not picking this C2, S is empty, T is still there. So empty string cannot be, like, we cannot find any subsequence in an empty string which is equal to some non-empty string T. So from here I'm going to return a 0 itself. And everybody 0 plus 0, 0, 0 plus 0, 0, 0 plus 0, 0, 2 plus 0. We are going to return a 2 from here. 2 plus 2, 4. So in total, you can see these are the 4 ways, right? You can say A2, B, C1, A2, B, C2 from this area, and these two things I am able to form from this area. This is the whole, you can say, recursive tree using memoization itself. We have of course eliminated a lot of work, right? And yeah, I hope this is clear to everybody. Of course, the time complexity, if you only write recursion, right, it is O of 2 raised to the power n, it's exponential, right? The number of calls you are making raised to the power of the depth of the tree. That is the recursive, you can say, time complexity analysis. If you are having troubles in understanding recursive time complexities, you can comment down in the comment section. I can make a video on that as well, right? So 2 raised to power n will be time complexity for the recursive code, but if you use memoization and you optimize it, the time complexity will be n square. From exponential, you are simply getting a square time complexity. I hope this is clear to everybody. Let us see the generalized approach of recursion, then quickly code this out. To generalize the approach itself, I'm simply going to do a simple thing, which is basically, let's write the pseudocode. Recur, S and T will be passed, the two strings will be passed. I is the pointer which will be pointing to the ith character of the string T. Of course, you can see in the code, I'll not be cutting the string, right? Like, just like I'm cutting it here. A2, I've removed A1 from here. I'm not removing them actually. I'm removing them virtually by keeping a track of indexing, right? So I index, right? Along with this, I'm going to have a J index, right? This J index is going to point on whatever, you can say, character is the first character from the string T. I hope this is clear. I'm not actually cutting the strings, right? Cutting the strings and making new substrings, which will of course increase the time complexity a lot. So I'm just using 2 pointers, which will be iterating over these 2 strings itself, right? So full focus, full focus. Dekho. If somehow j becomes equal to t dot length, if somehow j becomes empty, just like this case, you can see, right? You can see. I've actually explained this in very great detail. You can see here. T is now empty. This means that I am able to, you can say, form the whole string T itself, right? So what am I going to do here? I'm going to return a 1. That I am able to find a way. I am able to find a subsequence which is equal to string T itself. Because string T is exhausted. That's why. Correct. Great. If this is not, like J has not reached the T dot length, if we are still having some characters in string T and I reaches S dot length, what am I trying to say? We are having some characters in string T, but we are having no characters in string S. Can you form any subsequence from an empty string which is equal to some string T? No, no. This case is where in the recursive tree. Look at this. This base case is here. So I will show you, just give me a second. So when we were not picking this B up, right? Let's see, we are not picking this B up. You can see that this particular case is exactly the same thing. We are not having anything in string T, string S. You can see from here. We are not having anything in string S, but we are having something in string T. So the thing I'm going to return from here is 0 itself. I hope this is clear, right? So that's why I complete the whole recursion, because you are able to see the whole thing exactly as I, discussed, right? So let's see. Okay. So when this is the case, I'm going to return a 0, because I will not be able to find anything which is equal to, you can say, string, any subsequence which is equal to the string T itself. Great, no issues. Now for the rest of the cases, there are 2 problems. First, if I can take, right? If I can take, if I do not take, not take. Let's write not take case first. If I'm not taking ith character, so recur for st. I'm not taking the ith character, so I will be moved to I plus 1. And can I say j will remain as it is? Correct. I was not able to match the ith character with jth character. This means that the jth character still needs to get matched with someone in the future. I'm moving I forward, but I'm not moving j forward. Where can you see this kind of case? Let's see. You can see that, here B is not able to match A, right? If I'm not picking up, right, let's say like this A2, if I'm not picking up this A2, can you see that ABC is getting passed intact, right? It is getting passed as it is, because this A is not been consumed yet by someone, because this A2 was not, I was not taking A1 as well as I was not taking A2 in this particular case, right? So this string T will be as is, this string S, you can say, will be shortened, right? So in the case of I, I'll be moving forward. In the case of J, I'll not be moving forward. When I want to take somebody, I can only take someone if S of I is equal to S of T of J. If this is the condition, you can see A2 is not equal to B. So when I'm trying to pick it up, I'm getting a 0, right? If the characters are equal, then only I'll move forward, recur for S, T, I plus 1 and J plus 1, because J is moving forward. Jth character was consumed by the ith character because they were equal. This means that I have to move J forward as well, I have to move I forward as well. So recur for S, T, I plus 1, J plus 1, colon. If this is not the case, then I'm going to return a 0. I'm going to consider a 0 for this particular thing. I hope this is clear. In the end, we are going to simply return take plus not take. I hope this thing is clear. I hope you understand ternary operators, because this thing which I have done here is ternary operation. If this condition is true, we are going to return this. Else, we are going to return this. We are going to store this in the take variable itself. I hope this is clear to everybody. I hope the pseudocode is clear to everybody. Let us move to the code itself, convert it into tabulation, convert it into memoization, and then wind up the video. So here we are in the code itself, and simply we can start it, and I'll write recur s comma t 0 comma 0. Initially s and I and j parameters. I is for s and j is for string t, right? These two things I'm going to start with index 0 itself, because I want to start them. You can start from end as well, but I'm starting them from 0, 0 because we have done the iteration from 0, 0 itself, right? So because I've taught you in a way where we are matching the first characters. You can match from the last characters as well, right? Public int recur string s string t int I int j. I hope this is clear. If j somehow becomes equal to t dot length, this means that string t is exhausted. It is finished. This means that I was able able to match all the characters of t using a subsequence of string s. String s. So I'm going to return a 1 from here. I have found a way to make string t. I hope this is fine. If, instead of j, I becomes equal to s dot length. This means that I am still having some characters in t, but there are no more characters in string s. Hence, I'll not be able to find any subsequences, right, which are equal to t. I'm going to return a 0 from it. That's it. Let's move forward. Now comes the pick not pick strategy. I can pick, or let's say I'll take, initially I'll say it's 0, right? Initially I'm saying it's 0. If, right? If s dot char at I is equal to t dot char at j, then only take will be equal to recur for st I plus 1 j plus 1, then only I'll be picking. Like, I'm not writing the ternary operator as I wrote in the, you can say, pseudocode of this problem, but you can definitely imagine from here that, if if these characters will not be equal, we will not be going inside this if condition, and take will remain 0 itself, right? So if we are able to pick these characters up, ith character, if I can pick the ith character, which means that if ith character is equal to the tth character, jth character in string t, I'll be calling for take, else I'll not call for take, right? Not take, not take. If I do not want to take a person, right? Simply recur for st I plus 1, but j will remain as it is. That we have already seen. Why? Right? I have to return take plus not take. I hope this is clear. And this is the whole recursion code for this problem. A simple pick not pick strategy according to what we have studied so far, right? So let's see if it's running. Yes, it's running just fine, right? One thing is there, right? If you want, of course, I'm not submitting the recursive code because recursive code will give us a TLE because it's 2 is power n, and you can see n is where the n is string's length. It is like you can say 1000. So I don't want to do that, right? What I do want to do, I want to consider this 10 power 9 condition, right? This was something I told you that we are skipping it for now. Now let's talk about this 10 power 9 now. 10 is power 9 plus 7 simply means that if somehow using, you can say, big additions, if you want to add big numbers with each other, they can overflow integer range, right? Addition of big numbers can overflow integer range. So to keep them inside an integer range, wherever you are doing any addition operation, any mathematical operation, you will take an integer mod md is equal to 10 is power 9 plus 7. You can say integer of 1e9 plus 7. What is 1e9? It is 10 power 9 plus 7 is simply, or you can simply write like this as well. So 1 2 3 4 5 6 7 8 9, 10 power 9 plus 7. I hope this is clear. Wherever you are doing a mathematical operation, like here you are doing a plus operation, just do this. Add them in brackets, add a mod sign in front of them. I hope this is clear to everybody, right? Add a mod sign from them, and this is what you want to do. From here as well, before returning, do a mod operation just to make sure that your answer will not go out of bounds. I hope this is clear how this particular number is able to keep, you can say, integers in the bound itself, because it's a very big prime number, right? And since it's a very big prime number, it will not be divisible by anybody, which is you can say smaller than it. Definitely, it's a very big number. That's why it'll be not be, and it will not be divisible by anything. You can say bigger than it as well, right? So what will happen here is that the numbers will stay between 0 to 10 power 9 plus 6 itself, right? Whenever you take mod 5, your answer will be from 0, 1, 2, 3, 4. You'll not get an answer which is equal to or above 5. So that's why it is used to keep everything in, you can say, bounded cells. It is, you can say, somewhat related to competitive programming. If it is not clear, I can definitely make a video on this as well. You can tell me in the comment section, right? Let's move forward. So wherever, in short, wherever you're doing a mathematical operation, add this mod operator to keep the integer in the boundary itself, right? So, and of course this code will not pass because it's a recursive code. It is having bad time complexity. Let us optimize this code, convert it to memoization, right? And before watching the memoization part, I advise you to, look at the previous videos, right? Previous lectures. This is a series which we are going through. I'll be using short tricks to convert recursion to memoization to tabulation. So if it's not clear, you have to watch the previous videos itself, right? Right. So there are some tricks which are like, which are there, which I use to convert these things, right, into recursion to memoization to tabulation. You should definitely take a look at them, right? So let us imply the trick. Let's start converting recursion to memoization. I'll copy this, paste it here. After doing this, I've got two recur functions, right? In this, wherever I'm writing recur, I'll rename it to memo. I'm calling it a memo function, right? And along with it, I'll pass a DP array. But DP array will be having two dimensions because you can see when we are calling, two variables are getting changed. So integer DP. I'm directly applying a trick here. Caution, caution, caution. I'm directly applying a trick here. If this trick is not clear, if you want to know the logic behind this trick, you should definitely watch this whole dynamic programming is easy playlist from the very beginning, right? Here I'm directly showing what the trick is, right? So write the DP array. The dimensions of that is the number of parameters which are getting changed. The two parameters S and T are passed as it is always. But you can see here I plus 1, J plus 1, they are getting changed. I plus 1 getting. So two parameters are going to be there, right, in the DP array itself. And of course, where you're calling the memoization function, you have to add a DP array here as well, right? Let me make code a little bit bigger as well so that it's visible to you all. So yeah. So DP array I've added here and here. Wherever I'm calling memoization, I've added DP there, right? One thing is remaining. Recall and remember. DP I comma j. If DP of I comma j is not equal to -1, I'm going to return DP of I comma j. This is recall and remember, right? DP before returning the answer, DP of I j comma j is equal to this. I hope this is clear. I hope the trick is clear. I'm not explaining this trick again because I've already covered this in the previous videos. You should definitely watch them out because otherwise the video will get more longer. It's already, I think, longer, right? So integer 2D array DP is equal to new integer s dot length comma t dot length. These are the dimensions of this DP. T dot length. Why s here? Why t here? Because this first parameter of DP you can see is always used by I parameter. So this is limited by s dot length and this is limited by t dot length because we are using j parameter and j is traversing on string t. That's why the second you can say inner array's lengths are t. Now I have to initialize every you can say cell in this particular 2D DP with -1 for integer I is equal to 0, I less than s dot length, right? I plus plus arrays dot fill DP of I. This area I'm going to, every ith area I'm going to fill with -1s. I am going to pass here return you can say memo. String s will be passed, string t will be passed, I, j and DP array will be passed. I hope this is clear. Let's try to run this code and see if it's working. All right, it's working just fine. Let's try to submit this. And yeah, it is getting passed, no issues. Let us quickly convert this code to tabulation itself. And again, I'm going to use a trick to convert into tabulation. If you are not familiar with these tricks, I'm not explaining these tricks again and again. I'm not explaining how these tricks are working internally. You can definitely watch the previous lectures, but to all those who are watching this series in a proper manner, for them it will be very clear what is going to happen next. I'm going to create a tabulation function. So let's create this tabulation function itself. So to create this tabulation function, I'm simply going to do public integer tabulation. And from here, I'm going to return, you can say, I'm going to take in S, T and the DP array as well. Just like we have seen in the trick itself. This is the trick. I'm again repeating and repeating. So if it's not clear, how am I doing the tabulation? you should watch this trick first, right? So let's move forward. What I want to do is I want to start some for loops, right? And the for loops will be, this tabulation is iterative code, right? And iterative codes need to have some loops, right? Loops, if else statement, this is what you can do in iterative codes, right? So integer 2D array DP. So two for loops I want, because there are, the DP is two dimensional, so two for loops. How the for loops will work, you can see in tabulation, we start from the base cases and we go towards, you can say, the starting cases, right? So here you can say j is approaching t dot length, I is approaching s dot length. So in tabulation, I'm going to start I from integer I from s dot length minus 1, I greater than equal to 0, I minus 1 is. I'm starting from the base cases for integer j is equal to t dot length minus 1, j greater than equal to 0, j minus 1 is. I hope this is clear to everybody. Now what I'm going to simply do, I'm going to simply copy paste these things. Like, I'm not copying the base cases, that's not what we require. I'm going to simply copy these things. I'm going to paste them here. Of course, I need the mod, you can say, variable. So I'll get it from here right now. So I'll get this variable and I'll paste this in the tabulation function. Let's look at this function again. So I've used two for loops. I've copy pasted the code from DP, like Memoisation here. The first step is wherever return is written, remove that. Here return is written. This is the recall statement. You can replace, you can say, delete the whole recall statement, because this is not memoization. We will remove it itself. Here you can see one return statement is there. I'll remove this return statement. And of course, I'll save the data and continue, right? So the first trick is replace every return statement with saving the data and continuing. Here I'm saving the data and continue will happen on its own, because this is the last line of the loop. That's great. Every return statement is gone from here. Great, 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 great. Now wherever I'm calling memo, replace this by accessing DP array. So here instead of calling memo, I'll do what? Here instead of calling memo, I'll access DP of something. What parameter should I pass here? Whatever parameters I'm passing in the memo function. So I'm going to write here I plus 1. I'm going to write here j plus 1. And here you can see that yes, I'm doing a memo call here as well. So I'm going to write here DP of I plus 1 and j, because here I'm passing I plus 1 and j. So I hope this is clear. Every memo call has been replaced by DP itself. Now you want to handle the base cases, because you can see that I plus 1 and j plus 1 can go out of bounds as well, right? So one thing you will do, that if you can say, you'll simply say that if you can say, let's see, for example, let's handle this case first. So if you can say I plus 1 is less than s dot length, then only you'll try to access this, else you'll say that 0, not take is 0. I hope this is clear. Here in this particular case, if now here comes the base cases, right? If j plus 1 is equal to t dot length, then take will be 1. I hope this statement is clear. If after including this jth character along with the ith character, because both of them are equal, after including them and j becomes empty string, there is one way I found. Else if I plus 1 is equal to t dot length, or you can say s dot length, this means that t is going to be 0 itself. There is no way that your s string becomes empty and t is there, so there's no way to do that, right? And here I'm simply going to write else here. So I hope this whole thing is clear. I hope all these statements are clear. Simply I'm going to return here dp I comma j, and that will be the whole tabulation code of it this itself. I hope this is clear. Let's try calling this, right? So here I'm going to call return tabulation. I'll pass s, I'll pass t, I'll pass 0 0 with a d, not 0 0, I'll pass the dp here directly, right? Let's try to run the code. Let's see if it's giving any errors. Compiler error. Okay, dp I comma j, not I comma j, I want to pass 0 comma 0, because we are calling memoization from 0 comma 0. Here we are returning 0 comma 0, right? Here base case is t dot length, here we are starting from t s and t dot length, right? So this, you can say, tabulation, the things are reversed. So that's why we say that top to bottom is recursion, bottom to up is top down. That's why there you can say, on either ends their order is different, right? So in tabulation, you're building up from the base cases. It is definitely passing, and it's passing. Great, right? This beats 18.64%. This can differ by, you can say, your system, maybe network traffic on lead code, right? This can change, but this code is definitely passing the test cases. I hope this is clear to everybody. Distinct subsequences. I hope you were able to understand all three, you can say, ways, all three dynamic programming paradigms to achieve this problem. First recursion, then tabulation memoization, or I can say recursion, top to bottom, bottom to up. I hope this is clear, and I hope you are enjoying the lectures. And yeah, if you are doing so, please support the channel by liking, and do tell me in the comment section that what you feel about these videos, what is your feedback, right? How would you like, if possible, that how can you optimize something here? Time complexities, if you want to know, then time complexities are definitely, you can say tabulation is n square, memoization is also n square because we are remembering solutions. Recursion is 2 is power n, definitely, because there are two calls and the depth of a tree can be as long as n, right? The length of the string s itself, right? So I hope this is clear. I hope you are enjoying the videos. I hope you enjoyed these videos. And yeah, thanks a lot for joining me in this video itself. Until the next video drops. Bye.